Hey everyone, hope you all are doing great. I am Parthuru, Events and Program Manager for Microsoft Reactor. And yes, I welcome you all to yet another episode of AI Spark. But before we start our today's event, let's go through our code of conduct. We are all here to learn together, participate together. So please be respectful of other people's views, understanding the differences, be kind and consider in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section and we'll pick it up from there. And now, I'd not like to delay further. I'd like to bring in uh, Vinayak and Shreyan for today's event. Hi Vinayak, hi Shreyan. Hope you all are doing
Hi,
great.
Hi, Parth. Thank you for having us. Welcome, Shayan, to another episode. Um, can you also share my screen, Parth? Like, we'll start off with the presentation as well.
Yes, the floor is all yours, and we have AS Park at lunch today. Great.
Okay. Thanks, Parth. Thanks for the introduction. Hi. So, I think some of you might have already seen uh, other episodes in this series, and this is like the fourth in the series, and we've been running this since February 13th. One episode every 2 weeks. It's a six-part series that we have, and I'll talk a little bit about that in just a bit. Um, Today, we are going to talk about multimodal support and image analysis. So, my name is Vinayak Hegde. I'm the principal AI advocate at Microsoft, where I work with startups, enterprises, and all kinds of developers to help them skill up on the AI skills. And today, we're going to talk about AI Toolkit and multimodality and how we can support that. Shriyan is a software developer at KPMG, and he has some cool demos that he has lined up, and we'll share the repos as well so that you can use them as the basis for building apps on your site. So a little bit about the series before we move on. So as said, this series has been running since 13th. Um, we will post the link to the earlier episodes. You can also look at the earlier episodes which are available on demand by scanning the QR code on the right of the screen, and it should take you to a place where you can register for all of the upcoming episodes, and you can also see the earlier episodes which are available on demand. So we'll be referencing some of the earlier episodes as well, because we covered, as you can see, we have covered RAG, we have covered embedding models. We also talked about small language models and local use cases. We'll also have given overview of the AI toolkit. So we won't be talking much about those aspects. If you are not aware of some of these aspects, my suggestion would be, post this session, please go and look at the earlier episodes as well, and that will give you a good grounding on the various aspects till this point, right? But if you have not watched the earlier episode, we'll try to kind of cover some of those aspects as well. So without further ado, let me just go into the presentation itself. So this is like the agenda that we're going to have today. So we will talk about what is multimodal AI. Then we'll do a short demo of multimodality, and then we'll go into use case where we are seeing in the industry what are the different use cases that are available, and how you can use multimodal LLMs in your industry applications. And finally, we'll end with a code deep dive and a app demo from Shreyan, where he will talk about interesting recipe generator. He's also written a nice blog on this, and we'll share the links also towards it, so you can try it on your own and actually also look at the code. So Shreyan will give us a code walkthrough there as well. Cool. With that said, we have been talking multimodal, but what is multimodal, right? Mode. When we talk about mode, there are different modalities. There are text, there's image, there's audio, there's video, there's sensor data. That could be 3D data as well. So all of these are different modes in which which you work with different LLMs. What is different from traditional ML models is that multimodal LLMs can actually work with different kinds of inputs, and also generate different kinds of inputs. A great example, and this is a great time to talk about this, because as some of you who are on X or Twitter, as it was called earlier, would have seen, a lot of people posting anime styled images with GPT-4o, and that is an example of multimodality, right? Like you give an image that is already existing, and then you kind of style it, or give it like certain prompts. So it takes in the image, the text, and then you can transform the image into a different style, right? So it's a good time to talk about that. So this is again, like, Chat GPT 4o is now can be said as working across two modalities, right? Like, which is text and images. It can also do other things as well, like audio and video. But we are in this particular presentation, we're going to talk about text and images, right? This is also how human perceptions work, right? Like whenever, like for example, when we go to a restaurant, we obviously see the food. We know the name of the dish, which is text. We also smell the food, but we also taste it. So we are using multiple different senses, and if we want AI to be more human like it, we have to be able to um, share with it all the and generate and share inputs which are um, similar to human cognition, right? So whether it is like text, images, audio, video, sensor, all of these are how we actually feel the world, and then we want the AI also to be able to mimic some of these kind of aspects right? So typically, whenever we use multimodality, it unlocks much more information, right? For example, if you share an image also has a lot more information as compared to the text description, right? So you can actually share documents, you can share images, videos, and work with each of these. And also on the generation side also, we'll see that it can generate each of these as well. And a couple of examples, I talked about GPT-4o, and the famous example that is actually trending right now, about changing images, editing them. GPT-4o does that. There's also a specialized version of GPT-4v, GPT for 4 for vision, that is there. There's also Clip, which I'll talk a little bit later. There's also a small language model. If you don't know about what small language models are, please go to the second episode in this series, and we talked a lot in depth about this. So 5.4, which is like very very recent, actually less than about a month old, or maybe slightly more than a month old. It is also multimodal, and you can check that out as well, right? So why use multimodal AI? So different modalities, I've said. For example, let's say you have a chart, and the chart has information about sales. Now I can give those raw numbers and I can query, but if I give that chart and I ask it to interpret it, or a image from a, say, PDF file, I can just take a screenshot or the PDF file itself, and then use reasoning capabilities on tables, on images that are there in documents, and combine different modalities where I can chat with the document, or incorporate that into any kind of search that I want, right? So multimodality kind of reflects our real world, because we format data, we visualize data. Some of it is like in terms of like maybe like a podcast, so it can be audio data. So all of this can be combined, and that knowledges can be used to pull out data from different modalities. It also gives us zero shot capabilities on unseen tasks, especially in this particular specific areas where there is a rich amount of content. And it can also enable creative generation, and GPT-4o example is a great way. You can do text to image, video to text. For example, you drop in a video, and then you can see subtitles of that video. Or even better, you can if you can find out what are the key frames, who are the actors in the frame. So you can do all of this creative generation. You can do storyboarding very very easily. So this is typically how we work as humans. So working with LLM feels very natural and very human like in this particular scenario. There are different kinds of architectures when it comes to multimodal models. We won't go deep into this, but just for information, you can have an encoder model where you separate encoders, like Clip. Just a second. Yeah, like Clip, which is basically contrast language image pre-training, which builds on a large body of work on zero shot transfer, natural language supervision, and multimodal learning. The idea of zero data learning dates back to almost a decade, but only most recently you have had like breakthroughs in computer vision as a way of generalizing this to unseen object categories. Similarly, you have the encoder decoder model where you can generate text from visual input. As I said, like it could be charts, it could be even memes, right? Like even memes have text. We can um, so you can actually pull out data from images and also generate data from images. And something like that, GPT-4 has become quite good at incorporating any kind of text into images as well, right? So it works kind of both ways. So Blip is another model that works, and then you can have the unified transformer, which takes in multiple modalities and uses same kind of transformer architecture for that. There's also cross interaction, cross attention mechanism that can be also used as a key interaction mechanism, where you have different kinds of inputs that are available. And you can do things like visual question answering, and we'll show an example of this when I do the demo. You can also do image text matching, you can do image captioning. So there are multiple different ways of kind of handling this. So we talked about multimodality, right? So multimodality works in multiple different ways, right? So you have simultaneous input of image, text, video, embedding fusion, earlier rate, cross attention, where one modality is kind of dominant, maybe an image is dominant, and then the text maybe does not matter more. So you can actually have interplay of different modalities that are there, right? For example, I can have a video and ask questions about that video. For example, if I have a surveillance video, like say um, in a store, like I have the output of a CCTV, I can say, what was the time when maybe certain racks were not stacked, what was the time when in which customer had to was really looking for certain maybe products but was not able to find those. So you can actually have the different elements in even as a video, and then can either storyboard or ask questions on it, and can grab either the keyframes or identify people in the frame, or identify the actions in the frame, identify violations in the frame. Good example is during say COVID, you wanted maybe all people in maybe a supermarket, which many people come and interact, to wear masks, right? So if there is any violation, it can actually detect those violations. So you can actually query using like text, and then it will actually be able to pull out those specific kind of keyframes. Similarly, the output also can also span multiple modalities. So you can have text plus image. You generate an image and illustration, and you can also generate the caption. This is especially true if you are using it for say accessibility. You also have like another many cases where you can actually have a text plus audio. So you can have spoken conversational responses. And a good example of this is like podcasts. I can extract specific key points out of the podcast, or if you're doing like a Teams call, you can summarize the item points from that. So this is also a good example of multimodality, where the input is maybe video or real-time video or audio, and then you are able to pick out um, specific modalities, either video or text. You can also maybe like summarize clips. If you have like say for example an entire movie, you can give that. There are specialized models where you can give the entire movie, and then it will generate a nice trailer with voiceover and maybe captions as well, right? So there are coordination challenges across modalities, but these are a couple of examples where multimodal outputs can be done. So I have talked a lot, but let me just maybe kind of refine all this and show you a demo. So let me just jump into the demo. Just give me a second while I bring up my screen. Okay, so I have here AI Toolkit. Let me load the models. It's taking a bit of time to load the models. So I have already loaded some of the models from GitHub. As you can see, Llama and GPT-4o, both of them actually support multimodality. So let me just load it in the playground. Right. So as you can see, as soon as I load the model, it's still loading. Basically, here it's via GitHub, so it's making a connection, and we covered this in the early episodes. You can see that it is activating this area, which is I can give it a file, or you can give it an image. Because I'm doing multimodal input, I'm going to give it an image. And let me just maybe pull out an image. Let me take this image of a kid bouncing a ball. Let me just open that image for you so you can see what that image, because you might not be able to get a glimpse of it. Just give me a second. So this is the image. I'll just put it on my screen. Right. So this is the image that is there, and as you can see, it is a image of a kid bouncing a ball. So what I'm going to do is I'm going to one sec. Yeah, I'm going to type here. I have given that image as an input, which is one modality. Now I'm going to give the prompt, which is text. What is likely to happen next? Right. As you can see now, the model is actually trying to interpret. Um, so let me go back to the image. So it has, so you can see a boy from the grooves on the ball. It has figured out, hey, it is a basketball. The kid is playing basketball. He is doing dribbling based on the action, and it is likely that he is preparing to either make a move, pass a ball, or take a shot, depending on the context of the game or the practice session he's participating in. Right. So not only is it able to actually figure out the particular pose, the game, but it is also knows what stage in our game it is likely to happen without any other information, and it kind of ties together it that with this world knowledge to predict what is likely to kind of happen next, right? So it has identified the game, the objects, the relationship between the objects, the likely sequence of event, where in the game it is, and then also what is likely to happen next. So it is actually generating output based on this. So now let's move to something more complicated, and similarly what we'll do is when Shreyan does his demo, we'll do an advanced version of this. So let's take another image. Go and pick up another image. This is of image of a fridge. Let me also just share it with you how it looks on the screen. So this is the image on the of a fridge. In the internals of fridge, I opened the door and taken a photo. And here I'm going to ask the model. Even actually, let me. It's going to give me an error. So let me just start a new playground. Sorry about that. I had to do this again. Because I already given one image in the session, so I would have to do this again. Oops. Okay, it's the same image, so I'm going to ask it, can you suggest a recipe based on the ingredients in the fridge, right? So now I'm asking it to figure out what are the different ingredients in the fridge, and then be able to tell me, like, how can they be combined, what is the sequence of events, what should be the cooking style that I should do. So let me just run this and let me see the output. Again, I'm using GPT-4o here, but we can do the same thing with Llama Vision Instructs that is here, because that also has support for multimodality. Right? So here it has given me like a colorful veggie and sausage stir fry, and it is also nicely telling me what are the proteins, what are the optional add-ons, because maybe some of the things in the kitchen they may not know, especially the garnishing. And so it is identified the bell peppers, red, yellow. If I go back to the screen, you can see that there are bell peppers, there are carrots, there are tomatoes, there's some fruits as well, and there at the bottom shelf there is sausage as well. So it has identified all of these, and now it is giving me the instruction to prep the ingredients, cook the sausages, cook the vegetables, and then kind of combine. So based on whatever is my pantry available in my pantry, it can actually generate this. So this is another good example where it's identifying what is there in the image, it's using its world knowledge to generate a recipe based on those constraints, and then finally kind of combining all of that knowledge together to generate like a text description of the recipe for me. Cool. So we'll see a advanced version of this when Shayan gives a demo, and we'll look at the code as well. So we'll extend this example uh, in detail. So let me go back to the presentation. So I wanted to show you, what does multimodality mean, and you saw a good example with images and text, and AI Toolkit has support for this as well now. So let's go into multimodal RAG, because that is one of the biggest one of the upcoming, I would say, usage of multimodality. So it extends standard RAG, which retrieves text-based document, So multimodality means that can handle text, images, audio, video, other structured data, 3D data, sensor data. It uses a multimodal context to improve generative model responses, right? So because you can have a lot of information in images, it could be ad copies, it could be marketing images, it could be PDF documents. All of these, as our real world actually has different kind of ways of storing documents, and can use all of these really, really well. And we covered drag much deeper in the earlier session, in session 3. So I would encourage you to go and talk about look at those videos, because we cover a lot of these, and the same thing that we did with RAG for text and embedding model. Similar kind of things can be done with the multimodality. So you can extend the knowledge that is available to a RAG and retrieve the right fragments across different modalities, right? So if you have like sequence diagrams, or like in say UML charts, all of these can be used like really, really well in multimodal RAG. Obviously, because it is multimodal, and interpreting images requires maybe some amount of domain knowledge. Similarly, you have to make sure that the retrieval is also more efficient, right? So whenever you're going, say, from text to image to audio and video, eventually the search gets computationally much more heavier than text, right? So you have to account for that. So maybe it will take more latency, more compute power if you're using multimodal RAG. So that is one of the downsides. So while you can use a lot more data sources, there is a cost that needs to be paid from a computational complexity as well. Embedding alignment, right? So we talked about embedding, and embeddings like text embeddings, for example, occupy a different dimensional space. And then you have images or text, images or videos. They also need a different embedding space, right? How do you kind of reconcile both of them is a challenging problem, especially in multimodal RAG. It's not a solved problem. People are still solving this, and it's a open research problem at this point of time, though there are some solutions out there. There are also context-less length constraints. So many LLMs have limited input length, which makes multimodal retrieval charging. This has kind of gone away, but because images again have a larger um, input size, I think sometimes that can be a challenge. And similarly, if you're video, then challenge becomes even bigger. Again, and finally, evaluation. We'll cover evaluations in the next session, but it becomes harder to benchmark correctness when responses involve images around it. And this is as it is hard for humans. So now imagine, training actually models also to do this evaluation. So, for example, in the medical context, you can have the report of a radiology as well as a radiology scan, right? So you need like expertise in that area to be able to do the evaluations, and then even annotate to make the model better. Cool. So I will talk about the use cases. Already we have talked about a few use cases, and then I will hand over to Shreyan to actually go through the demo. I just talked about this radio report generations from scan. So we know in some of the other series that I have done, we have actually featured entrepreneurs who are actually taking the image and then marking the image and in the scan, and also generating a report. And then there is also a human in the loop who actually reads through the report, reads through the highlighted areas, see really if it is a problem, or it is like a false positive, right? So human in the loop, especially in high risk areas, is very important. E-commerce, a good example is, I can just take I maybe saw a movie or I saw a video in which I really liked the dress, or the maybe the suit which a particular actor was wearing, and then I can take that image, take a screenshot of that image, and actually search and find it in the marketplace. And this is a good example of multimodal search, because I'm searching using images, right? Similarly, finance has a lot of charts. There are filings, the PDF documents, and if you want to kind of ingest and make predictions, or generate reports using this, then I think in finance also it's useful. Manufacturing, and also I would say autonomous car. A lot of the data is through sensors like lidar, radar, or image, or other kind of sensors, and they can be translated into reports using text, or there can be some action based can be taken based on those, like maybe shutting down the machinery or reducing the temperature. All of these can be done visually. Like if there's a car damage, then in insurance also you can see that certain I would say In insurance, for example, certain claims can also be filed, or it can be they can be validated. And finally, in media, we gave a couple of examples. You can do visual summarization, you can generate trailers, you can identify people, you can do storyboarding. There are lots of different ways of using video summarization. This could be like commercial video, or it could be like meeting video as well. So share the video and audio, and then from based on that, generate like the action items. So this is like an overview of what multimodality is, what are the different use cases. Without any other further ado, let me just hand it over to Shriyan, who can actually talk about this. We talked about this challenges, data alignment, tokenization, memory and compute cost, and also the evaluation complexity. So we'll just skip over this and just jump over to the demo. So Shriyan, if you can share your screen, and then we can just go through the demo to extend the example that I showed.
Sure. I think, Vinayak, that was a pretty good deep dive on all the multimodal aspects. I think even a few things I learned through this demo, but I think it was pretty deep and I really liked it. So now let's see how do we actually implement this in, through coding skills or to whatever it is. Like, I'll be deep diving into the hands-on part of it. How do we actually practically implement this, right? So again, to get started with, let me begin with the playground itself from where Vinayak stopped the last demo, right? So we can see that Vinayak actually loaded one of the model from GitHub. So if you recall from our previous sessions, uh, AI Toolkit does not just only allow you to use GitHub models, but also it lets you through other aspects as well, right? So you can have your own Ulama running in the background and you can utilize that, or you can also download from one of their models and run it locally. So I'll just use one of the local models for the demo now, right? So we have 5.3 Vision here. As you can see, the 5.3 Vision 128K is what I'll be using it, and also you have other models as well, 5.3.5 vision, and I think 5.4 is also available now. So you can use any of these. But for the demo, I'll be using a 5.3 vision model. So let me quickly load that here. Right. So it will take a while to load this model. So what it is doing is basically it is loading in from your memory that you have already downloaded the model from. And till it is downloaded, we can also see that there is a small icon here which says use all AI features and use only 5.3 native features. Right. So let me just click on that, and you can see that it is letting me to attach an image. Now I won't go through this particular part because we have already seen how it works in a playground. So let me quickly try to do the port forwarding here. So right, to do that, I'll go to ports, and you can see forward a port here. So let me click on that, and usually the port of my choice is 5270. You're free to choose any other port that you want, right? So once I do that, it says that my port is ready, so I can access this model remotely through any program or any application that I want to use it in, right? So let me first start with a very basic application. Here I'll show you how to kind of analyze a chart. So let me just quickly show you the image as well that I'll be analyzing. So this is an image, right? So I want to analyze through a vision model, I mean a multi-model. How do we actually kind of get more insights from this? So I have a chart. You can see that it's a temperature chart in versus the day. So it says Monday to Sunday, how was the temperature varied, right? So let me just try to see that through a 5.3 vision model. So to do that, what I will do is I will import the OpenAI library. You'll have to download this, and a base64. I'll just tell you why have I used base64 in a while, right? So it actually solves a problem for us of processing the images. Now I'll define the client. This is what we had done in the previous session as well. We defined a client to enable the communication between your program and the model that is running remotely on your server itself, right, on your local machine. So now I have to encode this image, right? So for the computer to understand that I'm passing an image, actually, I would need to encode this in my Python program. So what I'm doing here is I'm encoding that image using the base64 library that I used before, right? Then I have to give the path to my image. So here I'm keeping it static. You're free to modify this however you want. In the next tutorial, where I'll take it slightly to an advanced version and I'll create an application using Streamlit, I'll show how to dynamically set the path as well. For now, I'm just hard coding it to the image that I've downloaded, right? And then I'm just getting the base64 string of the same image that I've downloaded. Now comes the very interesting part. This is where the whole, I would say, the brain of the program lies. So whatever we did, I would say it's the pre-processing, and now is the main processing of the file. So I'm just defining the client here, and I'm defining the model. So to do this, now there has been an update on this particular AI toolkit. So it is very simple now. You can just go to this model on my left-hand side, right? You can see here it says 5.3 vision. So right-click on this and you'll get the copy model name here. So you can just click on this copy model name and you can paste it here. So let me just do the comment here, right? It's the same thing, 5.3 vision, 128K CPU, and you can see the following name, right? So then I have to define the messages parameter here, wherein I'll define the role as user, as in the user is asking, invoking the model, and type text and what should go in the text. That is what I'm defining here. And type is image URL, and what is the image URL that I'm passing, right? So that is again referring me back to this particular image path. Let me just try running this now. So it'll take a while to run this. So I'll just do Python basic.py. Now, why will it take a while to run? Is that it is running on my local machine. It completely depends on what type of hardware you own. So I have a decent enough GPU. So it will take for me around 2 to 3 minutes for me to run. So I can also show you the task manager here, how it is actually executing this on my local. So you can see that it is 100% utilization right now. And there's an inference. Yeah. Can you see this inference service agent? So this basically showcases that it is actually using my own CPU and not any remote, remote uh, cloud or anything like that to run this particular model. Right? So that's why it's taking a while. So let's give it some time till it loads. So also I forgot to mention, I have just asked what's in the image here, right? So to perform a better analysis on this image, you can also ask many reasoning questions around this. That what would you think that might have caused this change in this particular weather pattern or things like that. So you can perform a simple data analysis on an image. So a few years back, it was completely, I would have to write code and then get it out of that image, extract data, and then do it. But as you can see, as we have progressed in this AI space, we can do it locally and without any kind of cost parameters involved. All that is a prerequisite here is a good hardware that you own. Right. So let's give it a while. So just to maintain with the time that we have, so I'll just use one local model for now. Rest of the models that I will be using here would be a cloud-based model that will be rendered to me via GitHub. So you can also, if you want to use a local model for this case, all you have to do is change this model name and change the client to your local host, right? So it is the same way. Only difference I would be having here is the API key and the base URL will be changed. So I think it is taking quite longer time here.
Just one quick thing. Yeah, just one quick thing. It's also, I mean, we have talked about this. You can also use the external models using Ulama function. So we'll point to uh, a small tutorial that I wrote about this, as well as we have covered this in the earlier session as well. So in case you want to use some other maybe model that is maybe not available on GitHub, or yeah, something that you want to run locally, that is also possible.
Right, right. Again, depending completely on the type of hardware you use, choose the model that you want to run. Because whatever Vinayak just mentioned, the models, right, Lava, Clip, and all these, especially Lava is available on Ulama as well. You can run it. But again, be very cautious of using it because it completely depends on the hardware stack that you have. So I think it's taking a while. Let's give it some time. And meanwhile, let's move to the next tutorial that I have here. Right. So now all that I did was I kind of yeah. So in the meanwhile, as I just moved, I changed my screen. I can see on my terminal here. It says this is a line graph showing the temperature in degrees Celsius for each day of the week from Monday to Sunday. The temperature values are so and so for each day. So this is a very simple answer that it is giving, because I just had asked what is in the image, right? So if someone asks you what's in the image, this is how you would define it ideally. So if you want to have more reasoning on this, then you can ask questions like that, that, why do you think the temperature is varying? So it will come up with reasons for that. So that is how you kind of do it locally. So now let's try something different on the cloud, right? So I have an image here again. So let me just show that image. Right. So I think the hype right now, the IPL is going on in India at least. I think cricket is something that people are loving to watch. So let's do something around cricket here, right? So I've downloaded an image where you can see that there's a batsman who's trying to execute a shot here. So let's ask LLM. So for now, I'll be using the GPT-4o, which is again a multimodal available on GitHub, and I'm using this cricket JPG that I've downloaded, and I'm using it through my GitHub module. So I've changed the URL, respective URL that I have, and I'm also having my GitHub token here. So in the earlier case, when we had it on our local, there was no need of a token because it was running on your own premise. So this was actually not a mandatory parameter to be passed. You could have passed anything XYZ or anything like that. But now, since I'm doing a cloud-based thing, I would need a token here for authentication. So now I'm asking what's happening in the image, analyze it as a sports expert, right? So let me just ask this question to my cloud-based model. All right. So it is now doing the processing. Although the previous version took a longer time, this is not expected to take so that long time now. So let's just wait.
Yeah, because
Rest
the
of the
hardware
things
is
remain
much better. Yeah. So compared
correct.
to local, so you get the answer also pretty quickly.
Yes. So here you can see this is an artistic representation of a cricket batter in the middle of executing a shot. Here's a detailed analysis as a sports expert. So what I did is I kind of gave it a persona that behave like a sports expert. I've told this particular GPT-4o instance that you have all the knowledge of uh, sports critic, I would say, right? So it has now told what is it. So posture and shot analysis, focus, equipment, safety, execution, and intent, right? So now it is trying to understand from that particular posture. So as you can see, the batsman had one knee lower and other one in a semi-standing position. It says shots like these are often seen in a T20 or a one-day cricket where boundaries or maximum runs are targeted, right? Can you see this kind of analysis it is doing? I mean, I don't have much knowledge on this, but I would say, okay, this is doing much better analysis than me here, right? So dropping one knee provides stability. Why is he doing that? And helps the ball lift upward. So I would say that now it is targeting a 4 or a 6 here, right? This particular body language aligns with attacking play, commonly used to handle spinners or slow pace. I mean, I'll definitely say I didn't know this much knowledge on that particular image from what I had uploaded. But you can see it says the particular batsman is handling a spinner or a slower paced bowler here, right? And the background and visibility is again something it is getting from the image, and image captures the finally it's like a one word conclusion. What does it capture? So I think this is something that you can also use for image captioning. So I can try it out right here. So caption this image for me in 1 minute. So let's ask this again. Now, from a sports expert, I'm making it a social media expert here by asking it to caption an image. I can also add for LinkedIn for any other thing. So it says grace meets power as the batsman takes aim at a glory, right? So a very beautiful caption, I would say, from for an image that I've just provided here. So this is what LLMs are capable of, and this is what Vinayak was kind of trying to explain in the previous section where he was talking about image captioning and things like that, right? So very interesting use case. Next, let's move on to how do we convert this into an application, right? So what I have here is a recipe generator application. Let's say you have uh, you're you're alone at home and you don't know what to cook, or let's say you're a gym freak and you want to you want to maintain the calories for a gym. So accordingly, you can ask this LLM to help you out, right? So this is a simple recipe generator that I've designed. So it's a basic Streamlit application. What it does is it basically takes the input of images. Let's say your fridge, right? You're alone at home and you just click a photo of your fridge where there are all things placed. I don't know how is it placed in an order or not. And you can just upload it to this particular app and it will give you a recipe right away. So I'll just briefly walk you through the code before I give the demo of this application. So I'm just using Streamlit here. Streamlit is a framework that from in Python that we use for designing applications. And yeah, as you can see already, you'll get a repository link. This code is readily available, so you can just follow up me with the code. If you want to code it all by yourself, you can clone to the repository that you'll find it in the chat. And I'm just loading this .ini because again, you can do it locally as well. Let me just show the local one. Yeah, so you can do it locally, but again, I won't do it here because it will take a longer time for me to wait and then get the responses. For you to do it locally, you can do it like this: the port that you forwarded it to and /v1, and then there's no API key needed for local model run. So if you have your 5.3 vision downloaded locally and you want to use it, then there's no API key needed, and the rest of the parts remains the same. So let me explain it for the cloud-based one. So here I'm just loading the .env. So I have a .env file in which I've stored my API key. I'm just utilizing that here, and then as initially I started by giving a static image file. Now it is on the fly. I can upload the image. So I've given the image uploader thing here, and then I'm just checking what is the if there is no image or something like that. I'm just checking that, right? So I'm also giving a sidebar select box. I'll do one thing. I'll just execute this code and then explain you this because you can follow with me better. So to do that, Streamlit run app cloud.py. Yeah. So this is the application, I would say. I'll explain the code once you have the visual approach of this, right? So you have this choose your preference here. I can choose vegetarian or a non-vegetarian meal, and I can select for cuisine as well. It can be Indian, Chinese, French, or you can see all these drop downs. And this is the title recipe generator and small description what it does. A placeholder to kind of upload your images and a button to kind of say, uh, execute this image for me, and then please upload the image to get the receipt, right? So now you have the visual uh, hint of how this app looks. So it will be better for me to, it's be easier for me to explain you. So the sidebar, that is what I'm referring here: vegetarian, non-vegetarian. You can also include more vegan, non-vegan kind of a meal as well, right? Cuisine, I'm defining what type of cuisines are there for me to select from. And again, in the previous tutorial as well, I kind of highlighted why is it needed for me to encode the image, or else your image won't be processed by this particular um, program, and it will say that it's a invalid format for it to kind of be uploaded. So I'm kind of having a small, I would say, encoding step here where I'm encoding that to this particular base64 format, which is the format that your API accepts here, right? So I'm just defining the button. What does the button do? It's Ask Chef Gen AI. You can name it anything that you want. And then the model that I'm choosing here, right? So it will be a GPT-4o model for now. You can choose any. You can choose Llama. You can choose 5.4 as well. And if it's a base64 image, only then this particular code block will be executed. And again, this remains the same. Here I've just given a text that is pre-processed to this particular LLM, which says, I would say this is more like a system prompt. I'm telling what it should do, right? Strictly use the ingredients in the image and a generator based on the preference that you select from it's a vegetarian or a non-vegetarian, and from the cuisine that you select, that will be passed here. And then I'm just passing this image as a next step. Then I'm just having a output how it should look like, and then if nothing is there, just it says please upload an image. So this is a very basic code. Uh, Now I'll just execute it. So to execute, I've already done it. It's a simple streamlit run appcloud.py command, and in the moment you do it, you will have a streamlit application like this. You can change it and you can explore this application more. So let me just select a vegetarian meal, and let's go for Italian now. You can choose anything. I'm yet to have my lunch, so I'm hungry for anything it shows me here. So let me just upload this fridge image. So as you can see, there are a lot of things which I even can't understand what is there. I can just see a Tropicana juice and some fruits kept in here, and there's some, I would say, something in a box. So let me just open this. Right, I can see this. This is the image, right? So let me just ask Chef Gen AI and see what recipe it generates for. So I think it is, yeah. It's here, vegetarian Italian pasta salad is what it has recommended me, right? Ingredients here from the image. Again, it's very clearly specifying that it is not getting it from its own knowledge base. It is from what I've provided. Pre-cooked pasta. Oh, okay, there was a pasta here. I didn't realize it was pasta. But can you see how accurate these LLMs are, right? So but it's performing better than me here. Pre-cooked pasta salad, and whatever the ingredients you can see, it gives you instructions. How do you prepare? How do you prepare the dressing? Assemble the salad, add cheese, and mix and serve. The dish combines pantry ingredients with a touch of Mediterranean flair for a quick and easy vegetarian Italian dish. And you can see that since I gave it Italian, it is uh, kind of giving me that Italian slang here, right? So it says bon appetit in Italian form. So that is how intuitive these models are, and this is how you can create a simple recipe generator. Again, if you have any doubts of how did I do it, there's a blog which you'll find it in the AI Toolkit samples repository that has always already been shared in the chat. So I think, yeah, there's a lot more than that you can do. You can use it for a RAG-based application. Due to time constraints, we won't be able to show you the RAG demo right now. How do you prepare one? So what you can do is, let's say you have a document which contains some tables, some images and things. You can separately extract these and then pass it to your LLM, and then have a questionnaire with that, and you can do anything. Like you can do a financial statement analysis. You can do in healthcare something like what Vinayak already explained, right? So you can have a healthcare use case for that. You can have a financial use case. You can have any use case that you can think of, right? So maybe we'll come up with one more session where we talk about how to implement this rack. That will be a session in it's a standalone session that we can plan later. But this is in a nutshell that what you can do with just having a LLM call, right? So Vinayak, anything else that you want to add on to this?
No, thank you. I think some people were asking for the repo, so I have pasted the repo. But if you can just share my screen, Parth, then I have the repo here, and we'll also share some of the different. We'll share some of the different uh, tutorials. So if you go to this repo, this is the repo. Uh, github.com/azure samples, azure-sample/AI underscore toolkit underscore samples. I have also posted it in the chat, and you can see it on the screen as well. So just go to this particular repo, and all of the code that we talked about, it's there. Like the earlier ones that we did are in the basics. Then the RAG also is there, and then the multimodal demo that we did just now is also there. Also the blogs that we have written on this, right, which includes the recipe generator that we just talked about, or the RAG we have talked about. All of these are available in the AI Toolkit blog as well, and it also links to the series. So if you go to this repo, you have everything that you need. You have the link to the series, so you can see the on-demand webinars. You can go and read the blogs, and in the repo itself, you have all of the code that you can actually try and experiment with this yourself. Yeah, so hopefully that would be useful. Yeah, if you can just Parth, if you can just scroll the samples in the again as well, so just so that people have the link as well. Cool. So with this, I think we have come to the end of our session. So as I said, like we've talked about different things. We've talked about SLMs, like Phi and Ministral and Llama, small language models. We've talked about embedding models, RAG applications, and this one we talked about multimodal support and image analysis. So if you have not registered for the series, please scan the QR code on the right, and then you should be able to sign up for the series as well. And yeah, we hope to see you maybe in the later versions. So thank you for attending. Parth will also, in the chat, and also put the feedback form. So if you can just give us feedback on the series, that would be really, really helpful. Any question? I think we've answered most of the questions I'm thinking in the chat. So there were some questions about the extension, and the extension is like AI Toolkit. So we just talked about it. I can just show you once again for those who are new. So if you just go to the extensions tab in your VS Code and just search for AI Toolkit, yeah, this is the first extension that you will see. So this is what we have used to demo, and this once you install it, you will see the AI Toolkit icon appear on your left hand screen, left hand sidebar, which I'm highlighting here. And then it has the newer version also has bunch link to bunch of tutorials. And if you have the access to the repo, you can go and read the different blogs that we've written on these as well. Cool. So thank you very much, and we hope to see you in the next session on evaluations, where we'll continue our series. And yeah, if you like and subscribe and share to this channel, that would like really help for getting us like more viewers whom we can help with this series. Thank you so much. Thanks Rian, thanks Parth. Anything you want to add, Parth, or we can close the session otherwise?
Yeah, we can wrap the session. Thank you all. Thank you so much. Thank you, Vinayak. Thank you, Shreyan, for doing this. Let's get on with another episode of the AI Spark soon. And yes, thank you, everyone. Thank you so much for joining us today.
Bye bye.